lifting bags are one of the most useful sources of force today. The lifting capabilities, together with the 1-inch height, makes airlifting bags invaluable to many applications, including emergency services. Operating with air pressure, these bags can individually lift, spread, shift, or move up to 146,000 pounds. Constructed of neoprene, which is resistant to over 800 chemicals, and reinforced with 3 plies of Kevlar aramid fiber or steel wire, the airbag is capable of exerting tremendous forces within a small working area. Each bag is labeled to provide the user with important information as to the capabilities of the bag, such as height, weight, 118 psi maximum pressure, the cubic feet of air volume. A safety label also reminds the user about safety rules to be used during operation. The molded surface provides maximum friction against lifting and bearing surfaces to prevent slippage. The X on the bag is a centering mark. It's molded into the surface to assist in bag placement, providing for a safer lift. The air inlet fitting, which is molded into the bag's corner, provides an opening for a replaceable nipple. This air inlet fitting has a hex head, which enables the user to hold the fitting securely during installation or removal of a replaceable nipple. Replaceable nipples are used due to possible damage from improper placement, load shifting, or mishandling. The system consists of 4 basic components. First, the air supply, which is the source of air. Second, the controller, which is used for operation. Third, air hose, which is used for delivery of the air. And fourthly, the air bag, which is used to exert the force. The supply can be any source of compressed air. For example, SCBA, self-contained breathing apparatus, stored air cylinder, truck brake system, compressor, even a hand pump. Generally, in emergency services, the SCBA bottles are used. Their high pressure, 3,000 psi or 4,500 psi, is reduced down to a safe working range of 135 psi through the regulator. These SCBA cylinders allow for portable, fast operation, especially in confined or remote areas. 2 types are available, allowing users to choose the one that best suits their needs. The second part of the system is the safety relief and control valve, the controller. These single, dual, or multiple control units allow for precise control during inflation or deflating operations. With the built-in safety relief valves, the airbags can be operated safely up to 118 psi. Several types are available. The standard unit has 1/4 turn valves for inflation and screw-type deflation valves with internal safety relief. This type is common with industrial users. The dual deadman style controller is the most popular for use in the emergency services field because of its design. This controller requires the operator to depress and hold the operating buttons to inflate or deflate. These spring-loaded buttons prevent accidental operation during a critical lift procedure. Air supply hoses with a working pressure rating of 250 psi allow for the connection of the system components. All hoses are equipped with a male nipple and female dual locking coupling. The safety locking ring prevents uncoupling during life-saving situations. The heart of the system is the airbag itself. They're available in 10 different sizes, ranging from the smallest 1-ton capacity, which is 6 inches by 6 inches, to a 74-ton capacity, 36-inch by 36-inch size. Unpack and lay out all airbag system components and inspect for any damage. Install the male nipple into the air inflation fitting on each bag. These are tapered brass and do not need to be over-tightened. A snug fit is all that's required. Attach the carry strap to the controller if desired. Of most importance is completion of the warranty card. This not only records the system, It places your organization in our file to advise you of changes, new products, service bulletins, or other important information. Before putting the airbag system into operation, the operator and personnel in the working area must be properly suited to the environment in which they'll be working. Safety equipment is of the utmost importance. Hard hat, safety glasses or shield, proper hand protection such as gloves, protective clothing, and footwear must be worn to prevent injuries. Because airbags may be used in so many different environments, operators must be aware of the many hazards which they may be exposed to and should provide protective equipment accordingly. The sequences of operation depicted in this program are designed to present a broad range of approaches that may be applied in typical situations. Procedures discussed and evolutions demonstrated in this training program do not necessarily represent the complete operational maneuver and are not intended to illustrate all techniques available for these situations. Let's go over the basic operation of the airbag system. In this case, the air source we're using is a 4,500 psi SCBA cylinder with a 4,500 psi piston-type pressure-reducing regulator. The hand tight nut is tightened firmly. The outlet valve is closed. Then the tank is opened and the pressure adjustment knob is turned clockwise to increase the low pressure gauge to 135 psi. The setup is the same when using the 2,200 psi SCBA cylinder with a diaphragm-type regulator. Note that in extreme cold, care must be taken to prevent the rupture of the diaphragm. The tank valve must be opened slowly to prevent damage. The supply hose is connected to the regulator outlet. Note the dual locking coupling. The other end is then attached to the controller. Again, note the dual locking couplings. The outlet valve on the regulator can now be opened, allowing airflow to the controller. The operation of the standard controller is very simple. Inflation of the airbags is accomplished by turning the quarter-turn valve counterclockwise. This allows air to flow through the controller into the bag. Turning the valve clockwise stops the flow. Deflation is accomplished by turning the knurled cap on the safety relief counterclockwise, causing the manual opening of the safety relief valve. Clockwise rotation stops deflation. If pressure within the controller increases to 118 psi, the safety relief valve will open, preventing overinflation. The next controller we'll look at is the dual deadman safety relief and control valve. It's operated by depressing either of the inflating buttons. The inflating buttons have an oval symbol depicting an inflated bag. As the air flows, the pressure on the gauge increases. Note the gauge dial: green go, red no go. If the inflation button is held down until the pressure increases to 118 psi, the built-in safety relief valve will release. Depressing either deflation button, the flat line symbol depicting a deflated bag, causes the pressure to decrease. Practice this procedure several times to make sure you're familiar with the controller's features. Next, the supply hose is connected from the controller to an airbag. Remember the dual locking couplings. Now depress the inflate button. Air will flow through the supply hose and the airbag will inflate. We're inflating the bag here to 30 psi. Depress the deflation button, allowing the bag to deflate. Due to the tremendous forces exerted on the bag, inflation should not exceed 30 psi while the bag is unrestrained. We are now operating the controller with two bags connected. practice operating the bags simultaneously and alternately, inflating and deflating. As you can see, the operation of the airbag system is simple. Note that when using more than one airbag, the use of different colored air hoses enables the operator to rapidly identify the airbag that's connected to each side of the control valve. Before actually putting the airbags to use, let's see why airbags are capable of doing the remarkable. Think of your automobile, 2,000 to 4,000 pounds, lifted by the 25 to 30 psi of air in the tires. A tractor trailer, 75,000 pounds, held up by 80 to 100 psi of air. A tractor, 25,000 pounds, with only 10 to 15 psi in the large tires. The reason is basic physics. Remember that little 6-inch by 6-inch airbag with over 1 ton of force? It works by the area, in square inches, times the input pressure. For example, if the work area of the airbag is 4.74 inches times 4.74 inches, the surface area, the working area, is 22.46 square inches. Times the force per square inch of 118 psi results in a total force of 2,650 pounds, over 1 ton. A large 36-inch by 36-inch airbag is capable of exerting up to 146,000 pounds of force with input pressure of only 118 psi. When an airbag inflates, the working area, that is, the area that's actually in contact with the load, decreases, causing the capacity of the bag to decrease. These illustrations show approximate lift versus weight. Remember that loads are generally tilted, causing the load to become lighter as the height increases. Keeping this in mind, we obtain the maximum capabilities of the MaxiForce airbags by using the largest airbag possible, by the use of proper cribbing when available, and by using 2 airbags to gain additional lifting height. Shoring or cribbing is a vital addition to lifting when using any lifting device, jacks, hydraulic tools, or airbags. The amount of shoring or cribbing required is dependent upon each need. Users should try to have enough available to handle most typical requirements. Here are several key points to remember when using cribbing. Have a firm base. Cribbing can be used to support the bags on soft ground. Always have a solid top layer to support the airbag. The use of a box crib provides additional height. Cribbing can be placed to protect the bag from damage from surfaces or objects. While operating airbags, remember these basic rules. The higher the lift, the less stability due to the change in the center of gravity. Tilting an object causes weight transfer and possible load shift. Single-point lifts can be a balancing act. Be cautious. Airbags do not stabilize. They aid in stabilization. Now that you have an understanding of airbags and their operation, let's put them to actual use. Airbags have applications in many different areas: industry, mining, agriculture, rescue, utility, military, and railroad, to name a few. When you see an example of airbag use, keep in mind the function of the bag: to lift, force, spread, or bend, as opposed to the specific task being performed in the example. Realizing the function of the airbag as a force-exerting device will help you to utilize airbags in many different ways. Before we actually start to operate the MaxiForce airbags, let's identify several safety rules. Only trained and qualified personnel shall operate this equipment. All personnel using and assisting must wear proper safety equipment, including head, eye, hand, body, and foot protection. All non-essential personnel must be kept clear of the operating area. Always block and secure the load as it's being lifted. Never work under a load that's supported only by airbags. Remain clear of operating area of the airbags. And never operate the airbags without a safety controller. Assemble all components needed at the work location. Connect the air hoses to the regulator, the controller, and the airbags. Position the airbag, in this application under a concrete slab. Depress the inflation button, allowing the bag to inflate. As the slab is lifted, cribbing is placed to ensure safety. This is a basic, single bag, tilting lift. Next, the same slab is lifted using two airbags. Placing bags on both sides of the slab allows the operator to lift the slab evenly. As the slab is lifted, cribbing is again used to provide added safety. To lower the slab, the first row of cribbing is removed and the deflation button is depressed. As the slab lowers, cribbing is removed piece by piece. Note that when the deflate button is released, the bag stops deflating. A single airbag is positioned under a waste container, in this case, resting on uneven ground. As the bag begins to inflate, notice how the container shifts to the low side of the slope. When confronted with a lift on non-level surfaces, caution is the word. Gravity plays an important part in these lifts or movements. Gravity can be used to the user's advantage or disadvantage. If you're not cautious, it can be dangerous. Additional stabilization must be used to prevent the container from moving. An alternate method can be used by placing airbags in several locations along the low side of the container. By lifting under this side, you're opposing the force of gravity. In applications such as this, extreme caution must be taken to secure the load from shifting. Cribbing is required for any lift of this nature. To gain additional height, two airbags may be stacked on top of each other. First, try to obtain enough height by maximizing the operational height with cribbing. If this doesn't meet the height needed, use the two largest bags possible. If different sizes are used, place the largest bag on the bottom. Position the airbags using the centering X mark. This is extremely important. Making the load safe, in this case the automobile, is a combination of different operations: blocking the wheels, setting the parking brake, stabilizing, protecting the victim, hazard control. These things are always completed before attempting any lifting or moving operations. Use only the air pressure needed to accomplish the task. The lift might only require 50 psi. Don't overinflate the bag. When lifting or moving heavier loads, such as this truck, remember that lifting the center point does not mean the load is centered. Notice the cribbing and bag placement in the following lifts. As we open the doors of the trailer, we can see the uneven load. This is why the truck tilted when we lifted under the center. Moving the lift point to the heavy side, we can keep the load level. Care should be taken to protect the bag from heat or damage from sharp objects, such as a bolt or nails, broken glass, or from damage from things like a small working surface like an I-beam. Protect the bag from these potential hazards. By utilizing other components, we're able to operate more than two airbags at the same time. Y connectors and inline relief valves provide users with many possibilities for multiple airbag use. While the applications or specific tasks change, the operation and functions of the airbags remains the same. Here we see airbags utilized in many different ways. It's easy to see the unlimited uses for airbags. Remembering the operation and functions, airbags will become an important part of your equipment inventory. The following segment is designed to provide users of MaxiForce airbags with information concerning the care and routine maintenance of airbags, regulators, controllers, and accessories. Overall appearance and cleanliness is important to the operation of all equipment. All components of the system should be kept clean to provide dependable service. All MaxiForce airbags may be cleaned with mild soap and water. A stiff brush used to clean the airbags keeps the non-skid surface at its best. You can check for leaks by pressurizing the bag to 30 psi and watching for bubbles. A spray silicone lubricant is best for connectors, valves, and other accessories to guard against corrosion and binding. We're inspecting the MaxiForce standard regulator first. Make sure the regulator is clean. Check the inlet fitting. Make sure the gauge cases are tightly fastened. Check the gauge covers for any damage. Tighten the fittings. Check the outlet nipple. Check the operation of the outlet valve. Make sure the pressure adjusting knob operates properly. Now we're attaching the regulator to the tank. As the hand nut becomes tight, tighten the last quarter turn by turning both the regulator and the nut together. This secures the nylon seat. Check for flow through the regulator. Check for proper gauge operation. This is the MaxiForce 501 piston regulator. Make sure the regulator is clean. Check the inlet nipple and seat for any damage or foreign objects. Make sure the gauge screws are tight. Make sure the outlet nipple is tight. Make sure the pressure adjusting knob operates freely. Lubricate lightly with a silicone spray lubricant. Now we're attaching the 501 regulator to the air bottle. As the nut becomes tight, the last quarter turn is tightened by turning both the regulator and the nut together. Open the tank supply valve. Check the gauge operation. Make sure the pressure adjusting knob operates properly. Check for airflow by opening the outlet valve. Check the hose for any damage or nicks. Make sure the hose and fittings are clean. Lubricate the fittings with a silicone spray lubricant. Check the operation of the dual locking couplings. The safety locking ring, and for proper disconnection of the coupling. Next, we'll check the operation of the MaxiForce standard controller. Check the operation of the dual locking couplings. Remember, cleanliness is important. Make sure the valves operate properly. We're connecting the air supply hose to the controller. Open the supply line. Check the operation of the controller. Make sure the deflation valve operates properly. Check the operation of the safety relief valve. As pressure increases over 118 psi, the safety relief valve will open to prevent overpressurization. Now we're checking valves on the other side of the controller. Just because one side operates properly doesn't mean that both sides are okay. Before disconnecting the supply hose, shut off the outlet valve on the regulator. Then open both the inflation and deflation valves at the same time. This lets the air bleed down from the supply hose, so the supply hose can be disconnected safely. This is the MaxiForce Dual Deadman Controller. Check the operation of the dual locking couplings, including the safety lock rings. Check the controller for cleanliness. Look for any obvious damage. Lubricate the couplings. Connect the supply hose to the controller. And open the outlet valve on the regulator. Press the inflation valve to make sure it works properly. Press the deflation valve to make sure it also works properly. Remember to check the valves on both sides of the controller. Make sure the safety relief valve operates properly when pressure exceeds 118 psi. Shut off the outlet valve on the regulator and press the inflation and deflation valves at the same time to bleed down the pressure in the supply hose so the hose can be disconnected safely. All accessories must be kept clean and inspected periodically. Shown here are some of the more common accessories: the inline relief valve, locking tire chuck, industrial to MaxiForce adapter, glad hand, industrial twist lock connector, and other fittings and adapters. The ratchet should be checked to make sure it operates smoothly. Clean and lubricate as necessary. The belt itself should be inspected for abrasion or cuts. By keeping MaxiForce regulators, controllers, airbags, and accessories clean, lubricated, and properly maintained, you can be assured of dependable service for many years to come.